Hi guys. So in case you don't have a printer, you can just follow along with me and write down the questions that we're solving for. If you do have a printer, you could have printed out the review that I posted on Google Classroom. I know this looks different, but it's all the same problem. So let's go through this review together. If you need it, awesome. If you went through the whole thing and you checked your answers and you got it all right, then that's awesome as well. All right, so the first thing that you need to know how to do is how to find the square root. So remember, a square root is thinking, okay, what times what would equal 1? So in this case, the square root of 1 will always just be 1. So the answer to this first one is 1, because 1 times 1 equals 1. All right, so for the second one, remember every square root technically has a positive and a negative. So for number 2, this little negative sign is telling you that it wants you to write the negative square root. Now, when you have a square root around a fraction, this can also be written as the negative square root of 9 over the square root of 25. This is the same thing because the square root is around both my numerator and my denominator. So I think this is going to be negative. And what is the square root of 9? That's 3, because 3 times 3 equals 9. And what is the square root of 25? Hopefully by now you remember those. And that is 5. So my answer would just be a negative 3/5. If it had a plus sign, or I'm sorry, if it had nothing in front of it, you would just put the positive 3/5. But I wanted to make sure I put that negative sign in front of it. All right, and so for something like number 3, I know that my answer is going to be a positive and a negative, but I have to think, what is the square root of 1.69? Now, this is something we didn't really go over how to find this without using a calculator, and most of the times you will be able to use a calculator for this. So that's actually 1.3. I can plug into my calculator 1.69. I take the square root, and that's 1.3, but I want to make sure in my answer I say that that's positive and negative. So if I want to evaluate, this is 15 minus 4 times the square root of 36. So that's 15 minus 4, and I can say times, well, the square root of 36 I can simplify. This equals 6, so that's 4 times 6. Now I have to think PEMDAS, so I do this first. So I get 15 minus 24, 15 minus 24, and I keep going. So 15 minus 24 is negative 9. So my answer is negative 9. All right, for number 5, I want to take, again, this square root is referring to, I can say this is the same thing as the square root of 54 over the square root of 6. But am I going to want to do this? I want you to pay close attention. Am I going to want to do this? Is this going to help me? Is 54 a perfect square? No, and you can even check on your calculator. 54 is not a perfect square. So would this help me? No. My first step is I actually can, and since these are both not perfect squares, I think, well, what is 54 divided by 6? What is 54 divided by 6? 54 divided by 6 equals 9. So I can turn this into the square root of 9 plus 2 over 3. And then I can simplify, well, the square root of 9 is 3, so this turns into 3 plus 2/3. So my answer is 3 and 2/3. All right, so what about number 6? Number 6 is 10 times whatever PEMDAS, parentheses, whatever the square root of 81 minus 12 is. So this is 10. And I want to find first, well, the square root of 81 is 9, so I have 9 minus 12. So I think, what is 9 minus 12? That's a negative 3. So this is 10 times a negative 3. So my answer is a negative 30. All right, moving into section 7.2, this is talking now about cubed roots. I want to think what times what times what is 729. And so hopefully you have this in your cheat sheet. If you don't, you can always refer to the prime factorization method. But to simply put it, 729, the cube root is 9. 9 times 9 times 9 equals 729. So my answer would be 9. So then if I go to number 8, can you hear my sister just started her car? Okay, so number 8, I think, well, I can say these are both perfect cubes. So what is the cube root of 64 over the cube root of 343? Well, the cube root of 64 is going to be, I'm blanking, 4, because 4 times 4 times 4 is 64. And then the cube root of 343 is 7. So my answer is 4/7. Now for number 9, I want to look. Now, this negative right here tells me I have to think about what times what times what is going to give me that negative. Well, I know a negative times a negative is a positive. So then a positive times another negative equals that negative. So I know no matter what, my answer has to be negative. So my answer is going to equal something that's negative. I think, what is the cube root of 8? Well, the cube root of 8 is 2. And the cube root of 27, I can do these again separately, is, oh my gosh, I'm blanking, is 3. So my answer for number 9 is a negative 2/3. A negative 2/3. All right, so now let's evaluate. Well, all we do is we just simplify. We keep simplifying. So I know that the cube root of 27, well, that's 3. So 3 minus 16, I think about what is that? That's a negative 13, so that's my answer for number 10. Here I have 25 plus 2 times whatever the cube root of a negative 64 is. Now I think, again, what times what times what will equal a negative 64? Well, I know a negative times a negative times a negative will equal a negative number, so my answer will have to be a negative. And then what's the cube root of 64? Well, that's 4. So I know that this whole thing equaled 4. Oh gosh, another big truck is coming by. So now I have PEMDAS. So I bring down what I have, 25 plus 2 times a negative 4. I do this first. 2 times a negative 4 is a negative 8. So I have 25 plus a negative 8, or I can think 25 minus 8. And 25 minus 8, that gives me 17. So for number 11, my answer is 17. That was a good one. If you got that one correct, awesome job. Number 12. First, let's simplify and say, what is the cube root of a negative 125? Well, I know that that's 5, and a negative times a negative times a negative will equal a negative. So this right here simplifies into negative 5. I bring down the rest of what I have. PEMDAS tells me, can you hear my dogs barking in the background? My goodness. 3 times a negative 5 is negative 15 minus 27. Stay, change, change. So I can think about this as 27 plus 15 equals 42, but that's negative, so my answer is a negative 42. All right, let's move on to the next. So going into Pythagorean Theorem, your answer, so here for number 13, oh my gosh, my dogs are driving me nuts. So for 13, I want to know, so find the missing length. What is C? Well, C is my hypotenuse. Again, your Pythagorean theorem is a squared plus b squared equals c squared. Now, either of these can be, since this is C, so I don't know C or c squared, so let's just say that this is A and this is B. So then I have 12 squared plus B is 35, so 35 squared. You can use a calculator. I know 12 times 12 is 144 plus 35 times 35 is 1,225, which will equal c squared. So now I add 1,225 plus my 144. That equals 1,369. And to undo, I want to get c alone. It's being squared, so to undo the square, I can take the square root. That cancels out, but what I do to one side, I must do to the other. So my answer will be the square root of 1,369, which is 37. So c equals 37. So same thing for over here. This is b, so I know that I have a squared plus b squared equals c squared. I do not know what b is, so b squared stays as b. So let's see what my hypotenuse is. My hypotenuse, C, is my longest length no matter what. So that is, and it's across from my right angle. So that's equals 0.5 squared. And then this will be A, so 0.3 squared. So this is my equation. I'm now solving for B. So I can do this on my calculator. 0.3 times 0.3 equals 0.09 plus B squared equals 0.5 times 0.5 equals 0.25. And now from here, I want to get B alone, so I'll subtract my 900ths, subtract, and be careful with your decimal 900ths. I'm going to bring this up over here. So I can do this on my calculator. I have 0.25 minus 0.09, which equals, oh, I can see where this is going. So B squared will equal 0.16. And the last step, I want to take the square root of both sides to get B alone. This will cancel out. And the square root of 0.16 is, oh, look at that, nice and easy. I have a 0.4. And you can plug that in and think, okay, does that make sense? If this is 0.5, this is 0.3, does that make sense to have 0.4 here? Yes, it does. So that is your answer. All right, so approximating square roots. This is where we don't have perfect squares, but by hand, I want to think about what is this close to? We also want to classify. So when it says classify, I'm really just thinking, is this a rational number or is it irrational? So for example, if I'm thinking of the square root of 19, well, I know that this is irrational because it's not a perf square. And let's see, if I wanted to estimate the square root of 34, well, already I know that this is close, really close to the square root of 36, and the square root of 36 equals 6. So I could say that the square root of 34 is about 6. Now the reason I didn't need to compare it to another one is because 36 is so close to 34. I know that's the closest perfect square to it. So let's try to classify. If I have here number 15, well, number 15 is rational because it has a repeating decimal. And basically that tells us we know how it ends. We know, even though this goes on forever, we know what it goes on forever with. 16. 16 is irrational. Because why? Because it is not perfect, I'll say perf square. And then what about 17? 17 is rational. Because it is. It's a perfect square. So you know the answer to 17 is 2. Your answer is 2, is a value of 2. That makes it rational. So what about estimating the square root to the nearest integer? An integer is just a positive or negative whole number. So if I have a timeline and here's the square root of 14, well, I think if I go to the left, what's the next perfect square? So 14, 13, 12, 11, 10, 9. So that's going to be 9. So 13, 12, 11, 10, 9. So square root of 9 is right here, and that's 3. Well, if I go to this side, 14, 15, 16. 16 is a perfect square of 4. So I think the square root of 14 is closer to which one? That's going to be way closer to 16. So that equals about 4. So I could say the square root of 14 is about 4. Again, it doesn't equal 4. I do squiggly lines because it's about 4. Here, the square root of 90, same thing. If this was showing where the square root of 90 is, well, I know that the square root of 81, so if this is 10 away, this right here would be about, so this is 80, this would be right here the square root of 81, which would equal 9. And let's think, if I go 90, well, 100, that's 10 away. 100, I know that, well, that's going to be 121, so that's pretty far. So a square root of 121, oh, I'm sorry. I'm totally forgetting. Here's the square root of 100. The square root of 100 is 10. This would be 11. So I think which one is the square root of 90 closer to? 81 or 100? Technically 90 is closer to 81. It's only 9 away from 81. It's 10 away from this. So it is closer to 9. So I could say that the square root of 90 is about 9. And our last one I have, here's the square root of 175. And you can even look, take out your cheat sheet, and you can just look right there and say, which are the two, which is 175 in between which two perfect squares. So this one I know really the closest one is going to be 13, because I know 13 times 13 is 169. So the square root of 169 is 13. And then if I say, well, what is 14 times 14? Ooh, well, that's 196. So that's going to be a little bit further away over here. 196 is 14. Which one is this closer to? It's closer to 13. So the square root of 175 is about 13. All right, and our last page, this is the last thing that we learned, was about using the Pythagorean Theorem. Where am I at with time? Okay, sorry, I know this is kind of long. Hopefully you can just skip through the video and just watch the descriptions on the ones that you were confused on. So, is this a right triangle? So here, the longest length is your hypotenuse. So 80, it's going to be equal to 80. So I have to check a squared plus b squared equals c squared. 80 is my c. The other two, it doesn't matter. So 48 squared plus 64 squared. So 48 times 48 equals big number 2304 plus 64 times 64 is 4096. And that I want to know, is this equal to 80 squared? So let's add right now 4096 plus 2304. So that equals 6400. So I want to see, is that what 80 times 80 equals? 80 times 80, oh yes, equals 6400. So 6400 equals each other. Yes, so yes, it is a right triangle. What about number 22? So I look for my longest side. The longest side is 61, so that means that that's my C. The other ones I can just say are A and B. So I say that 11 squared plus my 60 squared is going to be equal to my 61 squared. Now I can plug in. I know 11 times 11 is 121 plus, well, 6 times 6 is 36. Add on my two zeros is equal to, let's see what 61 squared is. So 61 times 61 equals 3721. So let's see if both of these add up to 3,721. So I have 3,600 plus 121. Oh wow, so that equals it as well. 3,721 is equal to 3,721. So yes, a squared plus b squared did equal c squared, so this one is yes. All right, so our last one, go ahead and try this one on your own. It's the same thing. If not, I'll give you the answer. Oh, I see what I did. All right, so your answer to this one is no. Your answer to this one is no. All right, so for 24, I have a -2 and a -5. I want to find my distance. So remember, your distance between 2 points is going to equal the square root of your x2 minus x1 squared plus the difference of your y's, y2 minus y1 squared. So all you do is you plug in what you know into here. So this is my x1, this is y1, here I have x2, y2. So now I just plug it all in. So my distance is equal to the square root of, well, x2 is 3 minus a -2 squared plus y2, which is 5 minus a -5 squared. I know that 3 minus a -2, stay, change is 5. So I'm going to simplify this. This becomes 5, oops, this is 5. So 5 squared, which is 25, plus 5, stay, change. 5 plus 5 is 10, so this is now 10 squared. I can simplify. My distance will be equal to the square root of 5 squared is 25 plus 10 squared is 100. So my distance is equal to 125. Is 125 a perfect square? No, it is not, so I leave that as my answer. All right, and then the answer to your last one, following that same directions, is going to be the square root of 113. 113. All right, so I know that was a lot. Hopefully you just used what you needed. That's pretty much a review of what would be expected on your test, what's been on your homework. Let me know if you have any other questions, and thank you for watching.